Okay, let's get started. So I apologize for going over time last time. If I go over time, tell me to stop because that's a sin that I don't want to commit. I talked to the grader for the assignments, and he told me that assignments 6 and 7 should be all done by Saturday. So, should, right? So hopefully that will be the case, and then assignment 8 should be relatively straightforward to grade after that. For the tests, I was happy about the average. It was higher than the first 2 tests, so I was happy about that. Any questions about the test itself? If I made a total mistake in like adding up the numbers, or it's not recorded correctly, or something like that, just bring it to me after, and then I can fix that. But any questions about the test itself? Any other types of questions? Yeah. Yeah, I said soon. I originally put Monday, but I might get it out like Saturday or Sunday. So it would be like a normal quiz, like from Monday's lecture to Wednesday's lecture, but I'll put it up a little before just in case if you're not able to access. No. Next Wednesday. I think it says November 28th on it. Yeah, so next Wednesday, yeah. That'd be kind of ridiculous for me to bring it out today and then do today. So next Wednesday. Plenty of time for it. Other questions? Okay, so let's actually finish up polymorphism finally today. So I copied this out of the slides, and this will lead into what we're going to talk about next. So I have a superclass, which is animal right here. I have a cat and a dog class also. So do cat and dog inherit from anything? Yeah, how can you tell? Yeah, with the colon, public, animal, yeah. So a cat inherits from animal, dog inherits from animal. Good. So we have this function ID, which just prints something out. I declared it virtual in the superclass, as well as in the derived classes, but we'll get to that in a minute. So declared it virtual, what is that supposed to do? Yeah.
I think if we're calling the function, it'll know which class to make the function from.
Right. So if I have an animal, it should call the ID corresponding to animal. If I have a cat object, I call the one corresponding to the cat object if it has changed. If it's not any different, then I'll go up in the hierarchy to the superclass, which is animal in this case. So just to show you that this actually does work, 100% does work, I have a vector of animals. I create an animal object right here, a dog object right here, and a cat object right here. So and then for each of them, I call the ID function, which does the print. So what should you expect to print here? Well, it's looping over the animals. The first one should print what? Animal. What should the second one print? Dog, and the third one prints cat, right? Let's see. Not intuitive, right? So what is actually happening here? So this is something called static versus dynamic binding. Okay? So let's get right into that. So this is literally just this example copied out of the slides. So function binding in general is when should we look up which function to call? So should we look up, am I going to call the animal or the dog or the cat version? Should I look that up at compile time, or should I look that up at runtime? Well, if we look at our code in the example, then what we're doing right here is the dot says it's doing it at compile time. And the slides say this also, but we'll get to that. The dot here says, we're going to look this up at compile time. Okay? So because it's at compile time, then all the compiler really knows is this vector is of animals. It could be all animals or of dogs or any combination thereof. It has to make a choice. And so if it's done at compile time with static binding, then what happens is that it calls the superclass version, the animal ID, which is what we see here. And what is actually happening on the back end? So suppose that I have an animal, so I'm putting this in a comment just for you to answer what actually happens. So let's just make an animal object and then make it on the heap, for example. So I create an animal object and I call new animal on it. What type is this animal? It seems like a trick question, but it isn't. It's animal, right? Because it's on the left here. What if I change this to cat? What type is animal? So there are two perspectives you can take on this. Well, I declared the type to be animal, so you could view it as animal, but the actual instantiation of the object really has the code corresponding to a cat object. So you can look at it in one of both possible ways. And so that's the difference between static and dynamic binding. So the static version says, okay, the type is animal because you wrote the word animal on the left-hand side. Whereas the dynamic version says, no, no, no. You actually instantiated a cat object and inserted it into an animal object, which is exactly what is happening here because this vector corresponds to animal objects. It doesn't know whether it's going to get a dog or a cat or whatever object. And so all that it has are animal objects, even though they could be initialized to something else, like one of the subclasses of animal. So that's why we get what we have there. But suppose I do the other version up here, right here, where I have a pointer to an animals array, and I initialize them all on the heap. Yeah, I could use a smart pointer for this. That's not the point. So so it's exactly the same, except they're all on the heap now. So animal, dog, and cat. Well, it sees that this seems like an error because the dot here corresponds to static binding. Whereas if I'm doing things on the heap here, I need dynamic binding because when I put something on the heap, that happens at runtime, not compile time. Okay? So here I need to say, yeah, I want dynamic binding here, not static binding. And the way we do that is with an arrow. And I'll get to the slide about this. So if we run this, it gets exactly what we want. So it depends on your use case. I think the vast majority of the time you actually want to do this because the code will do the right thing for the right type of object. So if, for example, this one's an employee, the cat object is faculty, and then another one is research scientist, for example, then regardless of how the distribution of people is here at ASU, it'll do the right thing for the right person instead of doing the exact same thing from the superclass. So that's the importance of static versus dynamic binding. And another thing about this virtual up here. So in fact, you only need to put virtual in the superclass, not the derived classes. So if I delete the virtuals for the derived classes, then I will get the exact same thing. So let's talk about static and dynamic binding. So function binding is all that it really is figuring out which function to call at what point. So the main ones that we're going to be talking about are static and dynamic binding, which is what I was talking about before. So static binding just looks at the base class pointer and doesn't consider the fact of whether it's a subclass at all. So regardless of whether it's a cat or a dog object, if I declare it to be an animal on the left side, it will do whatever the animal code is, regardless of whether it's a cat or a dog object in reality. So this is done at compile time. Dynamic binding is it actually looks up the actual type and then figures out what to do. So if I actually declare it to be a dog object, even though I say animal on the left side, then it'll do the dog code correctly, or the cat code, or whatever. Yeah, so it actually looks up the object itself, and dynamic binding is binding virtual functions. So virtual functions are the way we achieve dynamic binding. If we put the virtual keyword on the base class, and then the derived classes inherit the same function, then whenever I have a subclass object, it'll do the right thing, or the thing that we expect it to do. Okay, so another thing that you could do is, how many of you remember overloading? So what is overloading? So almost. So it's functions of the same name. So the same name, but different number of arguments or types of arguments or whatever. So that's what overloading is. Same name, but different parameter lists. Overriding is where we're going to look at some function in the base class or a superclass, and then the derived class does something different. Okay? Yeah. So the way that we can achieve this in our code is, here I can just say override. And I was testing this earlier. I'm not sure why it's not in blue, because it's a keyword, but it should work. So I'm actually not sure if this will do the right thing, but let's just see. So suppose I delete. Okay. So just something to keep in mind, override actually doesn't do anything. It doesn't actually do anything. The only purpose of it is to help us understand when a function is actually doing something different than the base class. Okay, so this is just an indicator to say, this function is actually doing something different than the base class's implementation. If I don't put that, then maybe it's doing the same thing, but it's just a way of understanding that it's actually doing something different. But overriding is essentially what we were doing with the virtual functions anyway. So overriding, all it is there's some implementation in the base class, and then the derived classes do it's the exact same function in terms of the name and parameter lists, but the implementation is different. So great final exam question. What's the difference between overriding and overloading? Overloading is when you have the same name, but different parameter lists. And then the body could be the same or different. The overriding, by contrast, is the same name and the same parameter list, but the implementation's different. Okay? So in both cases, the name is the same. For overloading, the parameter lists are different. For overriding, the parameter lists are the same, but the implementation's different. Okay, so one possibility is, okay, I have some function. Let's just say for an ASU employee, we have a change ID function. So maybe you want to change your 10-digit ASU ID. Well, suppose we implemented that for ASU employee. Should, like, say, ASU professor have a different implementation for change ID? Does that make sense? No, not really, because the 10-digit ASU ID is shared among all employees. A professor doesn't have a different type of 10-digit ID or whatever. So if they want to change it, they should do the exact same thing that the employee did. Well, if we didn't restrict what we could do, then the ASU instructor or professor class can change or override that change ID function, can do something different. The way that we can prevent this is by looking at the keyword final. So final, all that keyword does is say, If you want to change this function in a subclass, override it in a subclass, you can't do it. Okay? So if I go back here and I say final, then it'll give me errors. Because it's trying to override a final function, but final prohibits that from happening. So if you want some code to be shared among all subclasses and you guarantee that all of them will do the exact same thing, put the keyword final there. So it's a good tool if you want to restrict what your subclasses can actually do. Okay, well, for example, if you want to have a superclass where the implementation is not really supposed to be defined. So if you look at the ID function up here, maybe like we want to print the name. So maybe if this function prints the ID or the name of the animal or whatever. But maybe suppose, for example, an arbitrary animal that's not like a cat or dog or whatever shouldn't have an ID. Only if you're a subclass should you have an ID, okay? Then, well, from what we know here, we have to put some definition here, but maybe we want to absolutely make sure we don't have any implementation there. So the way we can do that is by using an abstract class. So an abstract class is basically a way of enforcing this. So yeah, an animal is an abstract class. There's no animal that's not one of the subclasses, a dog, cat, or whatever. So we should never be able to instantiate an animal object ever, because we should only be able to instantiate a cat or dog object because those are actual animals. There's no such thing as an animal that's not something else. So an abstract class is a way to do that. So how would you actually do this? Yeah. So what you have to do is to say, we're going to leave the implementation to the subclasses and prohibit you from instantiating an object of this abstract class. So an abstract class is defined to have at least one abstract function. So then you may wonder, how do we make an abstract function? So the way we do that is by using a pure virtual function. And how do we do that? We use equals 0 here. So if we change this definition to say equals 0, then this ID function now is a pure virtual function. Okay? So then we can see that there's an error right here. Before I hover over the error, what do you think the reason is why there's an error there? And why it's on animal and not on dog or cat when I made this function pure virtual? Yeah. Right. So here I'm instantiating an animal object. But because this function is pure virtual, this class is now abstract. Okay? Because there's no implementation of this function. Because I declared it pure virtual, I say, you have to instantiate a subclass of animal here. You can't instantiate just an animal object. Okay, so that's why I actually get an error here. So if I delete that, then everything will be fine. So if we run this, we get exactly what we want. Yeah. This is just the way that they have chosen to implement this. I agree, it's not really a good way of writing it. I would prefer to say abstract or to say pure on the front like this, but that's not the way that they defined it. But I agree, that's the way that it should have been done. Yeah, it's just the way that they have implemented it. Any questions about what pure virtual means? So what's the difference between pure virtual and just normal virtual? Another great final exam question, which will not be on the final exam. What's the difference between pure virtual versus normal virtual? Right. So can I instantiate an object that has a pure virtual function? No. So if it's pure virtual, what do I know about the class? It is abstract, and so therefore I can't instantiate the function. And the justification is, well, if we have a pure virtual function, then there's no implementation of the function. So if I try to instantiate just an animal object and call this function, then what is it supposed to do? There's no implementation there. Okay? There's not even an empty implementation. There isn't any at all. So that's why you can't instantiate an animal object, because it's pure virtual. Yeah. I'm not sure exactly what you're saying. So if I have a pure virtual function right here, yeah?
Yeah, so then like inside of ID you have a couple lines, maybe you do something.
ID inside cat or animal?
Oh no, this is just like a code separation.
Oh, well, this is tied to an animal object. If I have a completely separate function, then that's not tied to an animal object. No, because pure virtual works with inheritance. So so inheritance is with classes, and so you can't have like a function that's just defined randomly somewhere not in a class. Yeah, because it's only with inheritance. Great question. Other questions about pure virtual? Okay, so let's yeah. So this is basically what I was just saying. It cannot be instantiated because we have a pure virtual function. It has no implementation. You can only inherit from it because you can't instantiate it. If you have a class that derives from one of these classes, like animal, then you must override all pure virtual functions if you want to instantiate it. Right? If you want to instantiate it, you can't have any pure virtual functions at all anyway. So you have to override them, provide an implementation for them. So override is not just a different implementation. It could be that we're providing an implementation for a function that didn't have one before, namely a pure virtual function. Yeah. So yeah, you have to have a concrete member function, one that actually has an implementation. Okay, so so inheritance, we've said already, is a relationship between classes. One thing is another thing. So like a cat is an animal, a dog is an animal. Is an animal a cat necessarily? No, so inheritance always goes one way. You can't have one thing that is something else and the other way around. So it's only one way. So inheritance is a relationship. An undergrad is a student, but a student not necessarily is an undergrad. It could be a grad student. This is basically the other things that I was saying before. So a mammal is not an animal and not the other way. A poodle is a dog and not the other way. So composition from before, remember, is when we have the has a relationship. So an object has an object of another class. You got a question?
Yeah. So if you say you have like animals and then you have mammals and then you have like different kinds of mammals, so would you need to inherit from the original animal class? Or if like the mammal class inherits the animal class, could you just inherit from the mammal class?
Great question. So it depends on what you're actually trying to do. And there are pros and cons of each. So in your example, you have animal with mammal and then different types of mammals. Then the best situation from what I can understand is a mammal inherits from animal and the other mammals inherit only from mammal, not all the way up. So you can have compositional inheritance, meaning that you can have a chain of inheritances all the way down. But you could, for example, have the other mammals inherit from animal. But the issue is, if the mammal code has different functions that are specific to a mammal, then you'll have to re-implement them for the other mammal classes because it's not inheriting directly from mammal now. Yeah, so so when you're trying to do inheritances here, try to inherit from the closest relative to what you expect. So like you're inheriting from your parents and not necessarily you skipping your parents and going to grandparents. You inherit from your parents, but of course this is the real world. It's not exactly the same, but yeah, you want to inherit from the closest relative to the class that you're considering. So composition, remember, is the has a relationship. A class has another one. So like if we're making a class that has a vector inside of it, then whatever class we're making has a vector. But it's not the case that like something is a vector. So understanding the difference between has a and is a is really important here. It's the difference between composition, which is has a, versus inheritance, which is a. Good. Yeah. So that's just something to keep in mind. Any question on polymorphism? Okay, so I want to get onto the next set of slides. I want to hopefully get through this by Wednesday next week, but we'll just see what happens. So this is where the expressibility of C++ really, really takes off. So it doesn't give us much more power than what we had before, but the expressibility is far better with these three tools, namely exceptions, templates, and the STL, which stands for Standard Template Library. So let's just say that we're implementing some function, and maybe it's not in main, for example. And then what happens is they enter two numbers. Okay, so they enter an integer A, integer B. And then maybe our code prints A divided by B. Okay? Question for you. What if they enter 0 for B? So remember, it's A divided by B. Well, that may give a crash to our program, right? So what do we usually do? Well, from what we know so far, we say if B equals 0, then what would be a same thing that we could do? Well, what we can do is say we print, you fool, you entered a wrong value for B, and then what do we do? What function should we call? Or return 0 if we're in main, or if we're not in main, what should we do? Exit 0. Do you think that's a good thing that we should do? Well, think about this. Suppose that we actually do that. We print the you fool error, but then we want to actually continue the program and potentially do other things, maybe ask the users again. Well, if we're doing exit 0, that's not the right thing to do. Well, if we don't handle the error at all, we just say we print something wrong and then just continue normally, then I don't think that's the right thing either. So what exceptions are is a middle ground between the two. It tells you, yeah, some error happened, but the change here is between exit 0 and exceptions is that exceptions allow you to exit gracefully. Okay, so you can receive the error, the exception, and then you can decide what you want to do based on what type of exception you get. So maybe in our example of the A divided by B thing, we get some kind of numeric error. So like you entered a wrong numeric value. So then in our code, we can say, oh, we got this numeric error. Then maybe we can print, you entered a wrong numeric value or something. And then maybe some other type of error that they entered something incorrectly. Maybe they entered a character instead of a number by accident. Then we can have a different type of exception there. Then other types of exceptions along the way. We can receive any one of those exceptions and then handle whatever happens based on the type of exception that we get. So it's just all exceptions are, they're just objects. There's nothing special about an exception. But it indicates that an error had happened. Okay? So when an exception occurs, then either the program terminates, which is exactly what happened before, or we can have special code, and we'll get to that, some special code to handle the exception. And how you handle the exception is really up to you. The special code is called the exception handler. We receive the exception, and then we handle the exception. So how do we say, okay, let's just say that we're in the code right where the A divided by B actually happens. How do we actually communicate to anyone who uses this code? Yeah, they entered the wrong value. I want to show that an exception actually happened. So the throw keyword, and we'll see how to use it, is to say, I'm going to throw an exception. So the terminology for showing that an exception happened means I'm throwing an exception. Not sure why that's the word, but throw is the word for that. So what happens here is we need the exception handler to be able to handle the exception. So of course we want to have normal code that just executes as if nothing happened, but if in this code right here some exception just happens, then we need some way of signifying that an exception did happen. So the try block is a way of saying the code in here might throw an exception, it might not. But if it throws an exception in any code in the try block, it goes down to a catch block. Okay? So exception handlers are a try block at the top, then a bunch of catch blocks for each possible exception that may occur. Okay, so the try block is the code that we meant to execute, and then the catch blocks are for when we receive an exception if one occurs. Okay, so how do we throw an exception? So you can throw any object. So remember, exceptions are just objects. There's nothing special about them. But there are special types of exceptions that are commonly used in the library. But I can throw anything I want, both in real life and here. So I can throw a string, I can throw an int. Yeah, you can throw anything of any type. But the way that you catch something is if a string was thrown in this code right here, then we do this code in here. So anyone know what C_error actually means? What does it look like a lot? Yeah, it looks like cout and cin. So there's actually a third type of input-output, which is printing an error. So this is basically just to say, I'm going to print something relevant to an error. Okay. So let's see. Do we have an example? Yeah. So here in this code, we have a try block. So it's just like an if statement, but without parentheses. And then a catch block, which corresponds to catching some object of some type. And in this case, what type of object are we trying to catch in this statement right here? A car object, a chair object, yeah. So let's just see what happens. Let's just see that it actually works. So let's delete our code up here. And let's just say that we have a try block. And we're going to immediately throw just a string. Okay, that's all we're doing. We're immediately throwing a string object. Then we need a catch clause. So maybe we can have the catch that corresponds to a char object. And then, as I said before, we can have multiple catches depending on what type of objects we expect. So maybe I can have a catch for string s. So here, I'm expecting a string if it's going to be thrown, and then I'm going to name it s. So let's just see. So let's just see error. we found a car up here, and then just to see that it actually goes down to the string version. So then we print string here. So then if we run this, then it prints we found a string. And then look, it's actually a different color. So some IDEs actually can distinguish between C_err and cout. So maybe if you want to actually print some error code, C_err is a good way to do that. But we can see that it really did come down to the catch clause right here that corresponded to the object that we threw. So we threw the string object right here. So maybe if we change this to a car right here, and then we can throw C instead, the car that we just made right here, we should expect that we're going to go down to the car catch statement, and we actually do. Okay, so if we have, yeah, go ahead.
So when is this useful? Because you wouldn't just like throw like an object. You use like if statements and then like if something is like, how would you like actually take like say divide by 0 and that's your error? Like how would that actually work?
Right, so then what we can do is, for example, we have an int. Let's just go back to my example. So let's just say that we are CNing A and B. And then, so we haven't talked about the standard exceptions that are used in the standard library, but let's just do my example for now. So let's just say we have the code for if B is equal to 0, then we're going to throw just a normal string. So here, numeric error, just as an example. And then we can see out here A divided by B, just to get some program going. So if I enter 3 and 5, it should print 0 because 3 divided by 5 as integers is 0. But if I try to do 3 and 0, then I go down and do the catch statement. So this is mainly used in classes. So I have some throw statement, for example, in a class, and then whenever I try to call some function incorrectly with incorrect values, then it'll throw an exception, and then in our code, we're going to still get that same exception. Yeah?
Why did throw we found a string instead of numeric error?
So the string right here, this is just the object that was thrown, which is this S right here. So if we actually see error, oh, come on. It froze up on me. So the S, okay. So the S right here, that's actually the object that was thrown itself. But then afterward, we can do any other code that we might want to do. So I just print, we found a string down here. But if I printed S right here, then I'm going to get the oh yeah, so I have to do the input. So it actually prints the object because S right here is the object that was thrown. So maybe we want to, if we get some type of exception object, maybe it has some information about what actually went wrong. Maybe the line number on something that went wrong, or the exact parameters that caused the problem. And so that will be passed along to us that we could use ourselves in this object. Okay? Someone had a question, I think. Okay. So any questions just at a basic level on try catch statements and exceptions on a general level? So the main thing here is that if you use the throw statement with some object, doesn't matter what object it is, then we can catch those objects and then do some error handling, whatever the case may be. So an example of this, where this would really be used, suppose that, so how many of you use GitHub? So one of the frustrations with having a repository of code and then multiple people working on it at the same time is that someone can check out the code and then another person can check out the same code. They do different things. One person checks the code back in, but it now is incompatible with the other person's code because they may have mucked with the same code, right? So then how do you handle when there's a mismatch between the code that's in the actual repository and what this second person actually did? And so this would happen, so maybe this if statement here could represent, hey, there's some error here. We're going to try to throw an exception. So then we throw an exception that corresponds to maybe the lines that are different or maybe are conflicting. And so in the code where this second person's trying to commit the code to the repository, they can receive an error and say, oh, there is a mismatch on these lines. Which ones do you want to actually keep? Do you want to keep the ones in the repository or the ones that you made yourself? Okay, so error handling is really important here. So in that case, we would throw some object that corresponds to which lines in which files are having some issue. And then in the catch statement, we could error those lines, for example. And then the user can look at that and say, those are the lines that are causing the problem. And then I can fix it however I implement it in the catch statement. Okay? Any questions on the general level? Okay. So so this is basically how exception handlers work. You have a try statement, then one or more catch statements, depending on what exceptions you want to handle. Yeah, so it's just similar to a function, open curly brace, close curly brace. So the catch block has that one parameter, which is the object of some type that could be thrown at some point. Yeah. Yeah. Mm-hmm.
One is, can you throw variables that are variables, and the other is, can you catch auto?
Good point. That is interesting. So let's just see. So maybe I could throw B right here. So I can throw anything of any type of variable, literal, doesn't actually matter. So remember for auto, it actually has to be initialized to something, right? So I can't just have auto B and then B is initialized to something later. It has to be initialized to something. So, but the interesting thing there is you could have this auto object have a different type depending on what circumstances happen. So, but if I have, say, auto C is equal to some, let's do string error, and then I can throw C. So the type of C is string, but it's just we didn't type it ourselves. I'm not sure what happens if you could have different types depending on what actually happens, but that would be something to look into. But as is, auto knows the type of the thing on the right side.
Do you know if you could put auto in the catch statement, where you have string S, you put
Oh, good. Yeah, I don't think that actually works. Oh, well, that's the reason. So auto is not allowed in the exception declaration. So the interesting thing there is you could have auto as a function parameter, but I guess not an exception declaration, which is interesting. Maybe they'll fix that in the new C++ version. We'll see. Okay, any other questions? Okay, so we're done with those slides. Yeah, so here's just an example of this. So like if we want to do a square root example, if you have a number that's less than 0, then the square root of that number is not defined over the real numbers. So it's not a real number anymore. So then we can throw a string and then catch the string. It's essentially exactly the same example we had before. Yeah, so it encounters the throw statement in the try block. So it doesn't have to be directly in the try block. It could be in some other function, but it receives the exception at some point. But if it doesn't actually receive an exception, it just skips all the catch statements and just executes normally. Yeah, if it selects an attached catch block that matches the type, then it'll execute the code in the catch part, yeah.
So I don't know how you do this, but could you possibly have like your catch statements at the end of your whole program and have like the try block?
It has to follow immediately after the try block, Yeah, so it's like an if-else statement. The else has to immediately precede an if statement. Yeah. Yeah, so the control is you enter the try block. If an exception is thrown, then it'll start looking through the catch statements, hopefully finding a match. And if it does find a match, it'll execute the code in that catch statement. So if you don't actually implement all possible exceptions that could happen, then the program will terminate. So it's essentially doing exactly what we were doing before. So it gets us at least what we could do before, but now we can actually exit gracefully if we want to. So maybe we could end the program in a better way by printing some value and then exiting in a normal way, versus just saying exit 0 no matter what. So exception handling is really important here if you want to actually handle something that could go wrong in a program. Yeah, so you can have multiple exceptions. We were talking about that before. Okay, so in C++, we could have something called an exception class. So remember, you can throw anything of any type, but there are certain classes that are more helpful for exception handling than other ones. But the only difference here is that the catch block has to have that type versus int or string or whatever. So all it is just an object that is commonly used with exceptions. Nothing different there. Okay, so one exception that does happen sometimes, like in embedded systems, for example, is if you have a really small amount of memory and you are trying to do dynamic allocation for whatever reason, and if you can't allocate enough memory, then what'll happen is it'll give you an exception called a bad alloc exception. And so, is it anywhere? No, okay. So, that's just one example in the standard library. I don't expect you to actually use this or know about this exact function or object, but the key here is that there are various exception classes in the library so that you can actually use them for common tasks that you want to catch exceptions for. Yeah, so yeah, how to write exception handlers: write a try block, write a catch block. Okay, so this is the last slide on exceptions, and then we'll break after this. So what happens though is, suppose that we are doing a try catch at some point. Then what could happen is when we're calling functions deeper and deeper, so we call one function and then maybe it calls a different function and goes down and goes down and goes down, and then maybe this function way at the bottom throws an exception, then what you could do, for example, is propagate that exception all the way back up the call hierarchy. So this is called unwinding the stack. So when you have an exception, maybe in a class somewhere, or maybe you're several functions deep, you could propagate that exception all the way up to the top if you want to. So it's just different types of things of whether you want to have the exception flow through your code, or should you handle the exception yourself. So there are advantages, disadvantages of each. Okay, any questions before I just give you a sneak peek of my favorite part of C++? So I'm just going to briefly talk about this. So suppose we have a function that, like swap, for example, that swaps two values in an array. Well, what we have done so far is we can swap two integers or two longs or two doubles or whatever. But the difference is, if we're implementing it ourselves, don't I need 3 different functions versions for that? So if I wanted one for ints, one for longs, one for doubles, one for strings, etc., don't I need a different implementation for all of those? Even though they could do exactly the same code? What if we had a way of writing exactly one function that handles every case simultaneously? So that is all about templates, which we'll discuss on Monday. So I'll see you on Monday. Have a happy Thanksgiving, safe travels, all that stuff.